learners, welcome to Education Online program. In our previous lesson, we looked at forms of heat transfer, where we say there are majorly three forms of heat transfer: the conduction, the convection, and the radiation. And then we say that with the conduction, it is mostly in solids, then convection in liquids and gases, then the conduction, the radiation. So today we shall be looking at the differences between those three forms of heat transfer, because if you want to talk about the similarity, you'll find out that the common thing that cuts through is that they are just forms of heat transfer. So what are their differences? Let's take a look at that. We have the differences. Between conduction, convection, and radiation. Forms of heat transfer. So what do we think would be the differences between these forms of heat transfer? So we see that if we talk about the particles that each of the matter is containing, we find out that the particles are actually having some differences in them. So the differences in those particles also cause difference in the way the heat is being transferred. For instance, if we talked about if you look at the conduction, since we said it is in solid, how is the behavior of the particles of the solid substance? You see that they are compact. Instead of them moving from one point to another, they instead just vibrate. So when you come to gases and liquids, what happens is that these particles, they move. They are free to move around. So you see that one brings about a difference there, because if something is compact, it cannot move faster. So that means that the form of heat transfer in conduction is actually it is just fast but not faster. Can I say it is more like slow? Because these electrons do not have the ability to move freely. But then in convection, you see that the form of heat transfer there is a bit faster. Why? Because the molecules are spaced. Molecules in liquids are always spaced. They move about the liquid. So look at if you look at air, you find out that there the molecules are actually furthermore spaced than in liquids, meaning that during radiation the heat is transferred at the speed of light. So you see that it is very fast. For light to travel from one point to another, it is really fast. So heat is transferred faster during radiation than convection and conduction. So that one is one of our differences. We have our conduction, convection, and the radiation. So let's put it in form of a table. Like this. This one is to show us the differences very clearly. the table we shall include the conduction, we shall have our convection, and then we also have the radiation. So what is the difference there? We say the first difference comes from the way the particles are arranged in the substance. So we're saying that here it is very slow. For heat transfer here is slower. So if you come to convection, due to the fact that these molecules can at least move randomly, it is fast. So we shall say the heat transfer is faster. Then we have the radiation. For it, since it is moving in vacuum, we said it is taking the speed of the light. So we shall say it is faster in vacuum. So meaning when you have when it is the vacuum, that's why I'm saying that under the sun you can easily feel the effect of the sun heat, because it is moving in vacuum. And when it is in vacuum, meaning that for it the radiations to come all the way from where the sun is to reach you on the surface of the earth, it needs to have a very high speed. So you see that light is very fast. So if it is taking that speed, it can easily reach the surface of the earth. So what could be our second differences between this? If you look at the definitions, when we talked about when we were trying to define them, you see that we say that conduction is mostly in the solid particles and with direct contact of those particles. But then radiations, we say that that is a form of heat transfer that occurs in fluids, meaning the liquids and the gases. So what about the radiation? This radiation here occurs through electromagnetic waves. So that one there gives us the differences also between the three forms of heat transfer. So this one occurs in solids. They occur through solids, or you can say solid particles. So here we have, they occur in fluids. So we can say either it is the liquid or gases. And these ones occur through electromagnetic waves. So when you want to find the differences between two or three measurements or any other thing, first look at their definitions, because the definition alone might give you more than two differences between the elements. So you see that what we've just extracted there is from defining these forms. So let's look at another difference between these forms of heat transfer. So you find out that this one with conduction, the heat transfer is due to difference in the temperature. How is that possible? If we say that here it is due to difference in temperature. How does the difference in the temperature come about? Let's take a look at this example. You remove your shoes. You want to go and step inside, and the place is being cemented. If the floor is cemented, what happens is that most of the time you see that it is cold. So when you come and put your feet on the cement or the tiles, you see that you feel the coldness of the tiles. Why? This is because when you put your when you put your feet there, there was temperature difference between your feet and this tile. Probably your legs are like more, they are warm. So when you put it on the tiles, it's going to lose its energy to the tiles. And remember, you're a solid substance, and the tile alone is also a solid substance. So when you put your leg there, that heat loss to the tile will make you feel the coldness of the tile. So you see that transfer there, that loss and gain is showing us that there was a temperature difference between the two. So with conduction, the difference comes there because of the difference in the temperature of the system. It can be two or more bodies. So, but then if you come to convection, how do you get the heat transfer? The heat is transferred there because of the difference in the densities. Here is difference in the densities. If it is due to the difference in the densities, what causes the difference in the densities? When you look at heat changes the kinetic energy of a substance. And here with convection, since we are dealing with the liquid or the gases, what happens here is when you put your water on fire, it was, at first it is in the pan, it had the same density throughout. But then when you put it on fire, as the fire is heating, there will be increase in the kinetic energy of the molecules in the water. So you see that at the bottom of the pan, since there is some increase in this kinetic energy, it keeps on reducing the density of the liquid. So if the density of the liquid is reduced, what happens is that it will cause a temperature difference, because down here the density is being reduced, but then up the density is still high. So this one will have to move, the molecules will have to move to the top of the pan, where you find that there is a difference there. So you see, when it is moving, it is causing trying to bring down that difference between that temperature. That's why we are saying that for the convection to occur, the form of heat transfer, there should be the difference in the densities. So we are saying that with radiation, this form of heat transfer occurs on substances that have a temperature that is beyond 0 Kelvin. So anybody that has got this temperature difference, temperature that is above 0 Kelvin, will experience this, because we are saying that during radiation form of heat transfer, their object does not change in mass. So if it doesn't change in mass, does it mean that it will change its density? No, the density will still remain intact. There will be no change in that. And then on top of it, if you look at this, they are saying that it is due to a difference in the temperature. For the radiation, it doesn't actually consider that. It just comes and then the body absorbs the radiation. So we can also talk about the difference in what? We have the difference occur through heated solid object, which we say the heat transfer is by direct contact. That is still from the definition of conduction, because we say that this D here stands for direct. So if there is direct contact between these two objects, that means that the form of heat transfer that two objects will experience is known as the conduction. But what of the radiation? Do we need a direct contact between that? No. We are saying that convection occurs because of the movement. We said V stands for movement. So this V here, the movement in between the molecules of a liquid, will be the one to cause the heat transfer in convection. So we shall put it down here as this one is due to direct contact. Heat transfer is due to direct contact. Contact of the system. So with radiation, with convection, we are saying that for it is due to the movement, random motion of the particles. We want the actual. If it is actual motion between these molecules, it will give you the form of heat transfer known as the convection. So this one we say that the heat transfer is due to actual movement of particles. Which particles are we talking about? We mean the particles that the matter is containing. So what of the radiations? For it remains, it is due to the electromagnetic waves. So we have it is due to electromagnetic waves. We have not written there where we're saying that it is due to difference in the temperature. We have the difference in the density. So what do we have as our electromagnetic there? We are saying it is due to the fact that if anybody has a temperature that is more than 0 Kelvin, it will experience the radiations. When object has a temperature beyond 0 Kelvin, you can either say 0 Kelvin or 0 degree Celsius. So these are not the only differences we have, but there are so many others. So let us look at the factors that affect heat transfer, because if heat can move from one point to another, if we're saying that it is that process, obviously there will be some factor that will affect its transfer. So what are some of those factors? Have it as factors affecting heat transfer. So you'll see that there will be so many factors there, depending on the nature of the material. So we can have the first one as the temperature. We've been talking about temperature as the hotness and the coldness of a body. So how does temperature affect heat transfer? Since heat transfer is just the process, it is not actually stored in that body, but what is stored is the thermal energy. So how does this temperature affect? You'll see that when the temperature is actually very less in a certain point, and then when it is very less, that means that the transfer is a bit affected, but the transfer of heat will be very high. provided that the temperature difference between the two objects in play is very large. But then if you don't notice it that much, that means that the form of heat transfer there, the heat transfer there is going to be a bit lower. So the higher the temperature difference, that means that there will be very high heat transfer between the two systems. So we have it as the temperature difference between the systems. So we have other factors also, which is known as the thermal resistance, because with every solid particle, not even the liquid, you see that they are particles. If they are made out of particle, for something to move from one point to reach the other, there is always that kind of challenge. There is an opposing force that they will meet. So this opposing force there is known as the thermal resistance in heat, because if it is the thermal resistance, so what are those actually that causes that resistance? One can be dirt. When there is a lot of dirt, it affects the form of heat transfer. How does it affect the form of heat transfer? It affects it in a negative way. So you see that for instance, I have my can I have this, or I can get a container? A container is much better. So if I have my container, then it is very dirty from below here because of fire. It is very, so it has a lot of carbon below here. So this carbon here makes it very thick. So remember, I have to heat up this point so that the liquid in the container can transfer its heat from this point up to up. But then for this heat to actually reach the water, there will be a lot of resistance. Why? Because of this far here. So that is one of the kind of dirt I am trying to talk about. So we are saying that we have the thermal resistance. So what other factors do we have? We can have also the length of treatment. So how long are you allowing this object to actually absorb the heat? Did you allow it to absorb the heat for a very short time, or you've given it enough ample time to absorb the heat? So if you give it less time, that means that it is going to gain less energy. So when it gains less energy, that means the transfer of this heat from one point to another will be reduced. So that means that the time you're giving for a body to gain or to lose the temperature also affects the rate of heat transfer in that object. So we have it as the length of treatment. So we have so many of these factors. We have others like the specific heat capacity. How large is the capacity of the object to absorb the heat? So because when it absorbs it, it is going to store it in it as the energy before releasing it out. So how is its capacity there? We have the things like also the conductivity. Is this material you're using, is it a good conductor of heat, or it is a very poor conductor of heat? So the nature of your material you're using also matters. So you find out that when you're trying to get the factors affecting this, there are so many. You might even try to neglect others, like the length of the material can also affect the form of the rate of heat transfer, because the longer the object is going to be, for the heat to go from one point to the other is going to take a long time. So that is also another factor. So with this, since we have seen the differences, we know now how to define the conduction, convection, and the radiations. We have seen how they are similar to each other, how they also differ. These are not the only differences. There are also so many other differences that you can top up to under this. And then when we are talking about the factors affecting heat transfer, they are multiple. They go up to 9 or 10. Though for today we only had 3. You don't only stop there, but then you can add the rest. So with this we come to the end of our lesson. We shall meet again in the next lesson.